Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Hello dear students and welcome to CET JEE classes of the chapter sets. We'll continue to solve the examples connected to the union and intersection formulas. In the previous class we have already solved 7 problems. So today in this class we will continue to solve from question number 8. Alright, so let's understand the examples. These two examples are similar, 8th and 9th. Okay, so very similar. Let's understand. In a survey of 1,000 customers, it is found that 720 customers liked product A and 450 liked product B. The least number of people who liked both the products is, alright. So what you need to find is the least number who liked both. That means the minimum number, the minimum value of A intersection B, the lowest value, the least value, the minimum value of n of A intersection B is the thing that we have to find in this question. So what is been given? N of A, N of B, that is total number of customers, that is N of U. Okay, so let's write what is given to us. Well, understand. So N of A is 720 and N of B is 450, right? And what is N of U? Universal set, that is 1000. So out of 1000 you are making a survey. Well, now you have a formula for N of A union B, is it not? So that is N of A plus N of B minus N of A intersection B. Now you do not know the value of A union B, correct? You don't know the exact value of A union B, so you cannot find the exact value of A intersection B. So what you can find is only the least value. Let's see how. See, in this case what we need to find is the least value, the least number of people who liked both. That means the least value of this. When do you think this will be least? Okay, let's simplify, then you will get a better picture. So this is N of A 720 plus 450 minus A, N of A intersection B, and this adds up to 170 minus N of A intersection B. So this is N of A union B. Well, now understand. What do you know? The total number of customers surveyed is 1000. So out of that 720 like A, 450 like B. There may be some people who like some other product than A and B. There may be some people who do not like both the products, right? So the situation is this. You understand using the Venn diagram. You have the set A, you have the set B, you have the rectangle, that is the universal set, and here you have 720, here you have 450. Now what you need to find is the common region, the least number here. Alright, now you do not know the union. You do not know the union. Union may not be equal to universal. Okay, A union B may not be equal to N of U, the universal set may not be equal, because there may be some people who do not like both. They are outside the circles. Correct? Now, the question is, find the least value of A intersection B. The lowest value, the minimum value. When this will be minimum? If this is maximum, is it not? When this is minimum, imagine you put 10 here. Then what will be the value? 1160. Correct? Let me increase it. If it is 20, then this will be okay. Then what about this value? This will be correct. Okay, so when this is least, if this is maximum, see, if this is 1170, then this will be 0, minimum, least possible. But understand, what I am trying to say is, n of A intersection B is least when n of A union B is highest. Are you understanding that? Because we are subtracting here, we are not adding. Well, now what is the possible highest value of n of A union B? See, these circles, this total region is A union B, and that is always inside the rectangle. The maximum it can expand and become the rectangle. That's the highest possible. That means there are no people outside the circles. Union is equal to the universal. That's the highest possible. And how much is the highest? The maximum value of n of A union B is equal to n of universal, that is 1000. That's the highest possible. The rectangle has 1000 people, so that's the highest possible that can be achieved by A union B. So if that is 1000, so this is 1170 minus n of A intersection B. So that means what is the value of A intersection B? That will be, yes, 170. That will be 170, and that's the answer for this particular question. So what is the least value? 170, because the highest value of union B is 1000. You cannot exceed, you cannot go more than 1000. 1000 is the total number of people surveyed. So those who like product A, those who like B, those who like both, when you have the union, you cannot go beyond 1000. You cannot go beyond 1000. It can be less than 1000, because there may be people who do not like both. I hope that is very clear to you. Therefore, the answer here is 170. Well, now coming to the 9th question, exactly similar except the values, except the number of people. Well, so the question number 9, you have got totally 100 people, so universal is 100, and n of A is 72, those who own car, and those who own a bike is 45. Then the least possible number of people who owned both. So exactly the same question. So you have n of A union B, that is n of A plus n of B. You know this formula very well now. Okay, so n of A is 72 plus 45. So 72, you have 117. Well, now analyze. What is the highest value of A union B? I'm sorry, A union B, and that's intersection. What is the highest value of maximum value, highest value of n of A union B possible? So the highest value possible is just as n of universal. So you cannot go beyond universal. The maximum possible for you to achieve, okay, for union is 100. Okay, it cannot be more than 100. So if this is 100, that is equal to 117 minus n of A intersection B. So what is n of A intersection B? So that is 117 minus 100, which is 17. So 17 is the number of people, is the least number of people who like both, So you can never have 16 people liking both. The lowest possible is 17. 15 you cannot have. 18, yes, when you can have 18 here, when you can have 18 here, if this union is 99, correct? So if union is 99, you can have 18 there. Okay, so this is the highest possible. You cannot have 101, you cannot have 101, hence you cannot have 16 here, you cannot have 16 here. So I hope that is clear. Okay, so this is the way we find the least value of n of A intersection B. Well, let's move on to the question number 10. That also looks a little tricky one. Let's crack it. All right. Well, now there are 100 students in a class. In an examination, 50 of them failed in maths. So get this straight. You have totally 100 people in the class. All right. You have failed in maths. So there are 50 people who failed in maths. And I'll take YAM itself, and there are 45 failed in physics and 40 failed in stats. Well, this is the situation that we have. So we have totally 3 circles. We have maths, physics and stat, and then you have the universal set. So universal, the rectangle, has totally 1000 people and 50 in this total circle. In this total circle you have 50. Okay, and here 45 and here 40. Well, now 32 failed in exactly 2 of these subjects. So 32 people failed in exactly 2. What do you mean by that? That means there are 32 students who are either in this region or in this region or in this region. When you add these 3 regions, understand? When you add these 3 regions, see, these are the people who failed in exactly physics and stat. They did not fail in maths, therefore they don't come here. This is the region which represents the number of students who failed in all the 3. So this is the region which represents the number of students who failed in all the 3. So that means maths, physics and stat. Okay. Well, now exactly 2, it's not only this. So this is also exactly 2, that means maths and stat. This is also exactly 2, that means maths and physics. So when you combine these 3, when you add these 3 things, you get 32. That's the meaning of that sentence. All right. So now what we need to find? Only one passed in all 3 subjects. Then the number of students failing in all the 3 subjects. So this is what you need. Okay, so number of students who failed in all the three subjects, this is the region you need finally. This is the region you need finally. Now, one more thing that we have not checked. See, only one passed, not failed, passed. So, what is it? What is it? He did not fail in maths and he did not fail in physics and he did not fail in stats. See, what is this? Number of students who failed in maths. What is M dash? M dash means he did not fail in maths. That means he passed in maths. So, number of students who did not fail in maths and did not fail in physics and did not fail in stat. Only one passed in all. He did not fail in any. So, that is one. See, please understand this very clearly. Okay, well, now what we will do is we will take this quantity as x. That's what we need finally. So we'll take it as x. All right. Now understand. What is the formula that you have? Okay, what is the formula that you have for this? This is nothing but n of u minus n of A union B union okay, now this is M and P and S. Okay, so that is n of M union P union S. So this region represents the region covered by these circles. Okay, so that is union. What is universal? Universal is the rectangle, and there is one person here who is outside these circles, and that is intersection of the complements. So he did not fail in maths, therefore he is not here. He did not fail in physics, therefore he is not here. He did not fail in stat, therefore he is not here. He is outside the circles but inside the class, inside the rectangle. Well, so from here what we get is, we get this number, because this is 1. N of u is 100 and this is M union P union S. Okay. So that is the circle region. Well, now what is the union of all the three? M union P union S, that is equal to 99. Well, next we know the formula for union. Now what is that formula? N of M plus N of P plus N of S minus N of M intersection P minus N of P intersection S minus N of M intersection S plus M intersection P intersection S, and that is x. So this quantity is x. Now you know what is N of M clearly. Those who failed in maths, physics, chemistry, stat, that's there, no doubt. But what about this? You do not know that. That is not separately given to you. That is given as 32, and that too only this region. Okay. So what is M intersection P? So M intersection P is these two regions combined, and this region we have taken x. So if this is x, okay, and these three add up to 32, then how we can represent these three regions? Wait for a second. See, this is N of M plus N of P. We know these values, we'll substitute later. Now I am taking minus common, so that means this is intersection plus intersection of P and S plus intersection of M and S, okay, and plus N of M intersection P intersection S. Well, So I am trying to represent a region covered by these three quantities. Okay, so now I have got this region now, which I have represented here. Okay, which I have denoted here. So what is number of elements of m intersection p plus m intersection p is this, plus this region plus this region. Okay, so that is these three regions add up to 32 plus 32. Is it over? Because only this much is 32, but this see, when you have taken this region, that means you have taken x once. When you have taken this region, you have taken x twice, and when you have taken this region, you have taken x thrice. So here there is 1x, here also there is 1x, here also there is 1x, so that is 3x. Please understand this, and this is x, and this is 50 and 45 and 40. Well, so if you get this right, then there is no doubt you will answer this question, and union of all the three is 99. So substitute, what you need to find is x, that's it, you can simplify it. But I am repeating this again. Okay, so when you add these three regions, what you get is the sum of this region, that is the region denoted by, okay, these three notations. Now this is this region plus this is 32. So when you have taken this total region m intersection p, you have taken x once, x twice, x thrice, therefore 3x. This is not mentioned specifically. This is not mentioned specifically separately. So they have given the sum of these three regions 32. Okay, you have taken n of m intersection p, so that means you have taken x once. I hope that is clear. Well, I'm not going to repeat that again. Well, now this is 99, 50, and you have 95 and 1, 35 minus 32 minus 3x plus x, so that is like 1, 0, 3 minus 2x, and this is 99. So 2x is equal to 103 minus 99, that is equal to 4. Therefore x is equal to 2. So what is the final answer? What is the value of this x? This is 2. This is 2. Well, so that's it for question number 10. Thank you very much for watching. I hope you understood these solutions. Okay, so please keep watching this video. If you don't understand, please repeat. Okay, and go back to the previous videos and learn those questions first, then you will understand these in a better way. Look at this question. This question is based on the subset concept, okay, and union and intersection, of course, right, and the equality of two sets. When do you say two sets are equal? See, basically when do you say B and C are equal? If B is a subset of C and C is a subset of B. If both these things happen, then we say they are equal, basically. Well, keep that in mind. Then understand the concept of the complement as well. Let's begin with an example. See, you have to identify which is not correct, okay, which is not correct. So three things are correct, only one is not correct in this. So let's see which are correct and which is not correct. See, if the first one, if A is subset of A dash, then A is equal to 5 empty. If A is equal to empty, then A is a subset of A dash. That's the meaning of if and only if. It happens both the ways. Okay, so both the ways it must be true, then only you can write a statement with if and only if. Okay, well, now if A is a subset of A dash, then A is equal to null set. So if A is a subset of A dash, then A is equal to null set. How does that look like? See, if you take A is equal to 1, 2, okay, and the universal set, of course, I'm sorry. So 1, 2, 3, 4, I'll take universal set. Now what is your A dash? What is A dash? A dash is other than A, so 3 and 4. Now do you say A is a subset of A dash? No, A is not a subset of A dash because all the elements of A are not present in A dash. That's the meaning of A dash, complement of A other than A. When this will happen? When this will happen? When if A is a subset of A dash, if A is a subset of A dash, when that will be a subset of A dash? Only if A is null set. Okay, so if A is a null set, then what is A dash? A dash will be 1, 2, 3, 4 if A is a null set. Okay, so if now do you say A is a subset of A dash? Does this happen? All the elements of A, are they present in A dash? Yes, A is a subset of A because every null set is a subset. Okay, you take any set, what will be its trivial subsets? Trivial subset will be the null set and the full set, correct? Okay, so trivially empty set is a subset. So when this situation will occur, only if A is a subset of A dash, then A will be empty. If A is empty, then it will be automatically subset. So what they are saying in the first statement is correct. Okay, is correct. Then second option, what you have is if the direct part. So if A dash is subset of A, then A is equal to universal, and if A is the universal set, then A dash is subset of A. Well, now what we are saying is if A is universal set, okay. Alright, so go back to that example. Now, if A is universal set, what is A dash? A dash will be empty. A dash will be empty. So now do you say that A dash is subset of A? Yes, null set is a subset of A here. Okay, so if A dash is subset of A, then A must be universal. If A is universal, then that will be subset. If that has to be a subset, if that is a subset, then A will be universal. So it plays both the ways. So that is also correct statement. Now coming to this, A union B is equal to A union C. See, you have three sets here, A, B and C. So let me give an example for this. For the third option, see, you take the set A as A, B, C. You take the set B as singleton set, and the set C, you take it as the set C. Just an example, you can take any other example of the similar sort. Now, what is A union B? A union B is A, B and C. You don't write that B again because it's already written. You don't repeat any elements, correct? And what is A union C? A union C is A, B, C and that C again. So you don't repeat it. You stop there. Now are they equal? Yes. A union B is equal to A union C. Now do you say that B is equal to C? B is the set containing the element B, and the C is the set containing the element C. They are not equal. You don't have the same elements there. You don't have the same elements. Therefore, therefore which option is not correct? Therefore C is not correct. So that's the right choice for us. That's the right choice for us. Going for D, it's again B is equal to C. If and only if A union B is equal to union C. See, even though these are equal, this may not happen. This may not happen. And if this happens, these two need not happen. These two need not happen. Alright. So you can take the same example and check. But we got the answer already. Okay, answer already. Therefore, option C is not correct. Well, so thank you. We'll continue to solve few more examples for this chapter. Alright, so thank you for watching this video and keep watching to understand this chapter in a better way.
Don't forget to like our video and subscribe our YouTube channel for all the updates.